Hello, everyone. My name is Derek Cameron. I work on the Oracle Code Innovate team. We work with customers to build out solutions to use cases in a short 1 week time frame. Check out the URL. We work a lot with legacy customers that have been working with the Oracle database for many years. I myself have worked for Oracle for 26 years and with Oracle technology for over 30. And so today, what I wanted to do was for many of you out there who may not have been introduced or had a chance to work with the Oracle Cloud and the autonomous database, what I wanted to do was put together a more technical presentation on exactly what the differences are, the kinds of things that you do normally in an on-premise database and how you would do those and much, much more using an autonomous database. So let's get started. I'll be going into the database console. I'll show you how to create a new database, just touched on a few things to look out for. On the console, we've got a web front end to the database, many features. I will certainly not cover everything that's on the console. There's a lot there, and there's dedicated presentations just on some of these features alone. But I will cover the basics of SQL Worksheet. Very briefly, machine learning, that's a very big topic. We'll talk about data loading, how you can load data through the console there, data transformations, how you get a free sort of ETL tool for loading and transforming data from a variety of sources. And then we'll look at data pump imports. I'll also go into the SQL Developer Client and just point out the differences between working with, say, SQL Developer Java version and then the web. I still use that. I'm sure many of you would still continue using that if you've been working with it for many years. But of course, you've got many alternatives now with the web access. And then I'll be touching on some very cloud-specific features, DBMS Cloud, used to interface the Oracle database with other things like object storage. Look at the DBMS Cloud repo, which is now giving you integration in a GitHub repositories. If you want to keep your code in Git and you want to save code to Git and execute code directly out of Git, will you be using the DBMS Cloud repo package? Take a look at the SQL command line and then look at Liquibase. We'll do a quick sample of Liquibase, how to replicate database DDL changes across environments. And then lastly, just taking a look at Cloud Shell, where for a lot of things that I typically use maybe my desktop for, you can actually do in the Cloud Shell. So let's get started. I'm going to start by logging into the Oracle Cloud Console. I navigate by going up to the upper left. I go down to Oracle Database. We're going to be focusing on autonomous database today. There is also the VM versions and Exadata, of course. And within autonomous, you've got a data warehouse version, JSON, and other versions. So let's go into autonomous database here. And in my compartment, everything's divided in the cloud by compartment, permissions, etc. I've created in my compartment, I've created a JSON database. I will not cover that today. That's a big topic unto itself. I also deployed a database on a private subnet just to configure analytics against the private subnet using a private access channel. I will not be covering that either. I also have one here where I configured Active Data Guard against a copy of it in another region. This is the primary. The other instance is the secondary. Again, these are all just features that we demonstrate to customers. I won't be covering that. I'll be focusing today on this instance here. It's a data warehousing instance. Before I go into this, I'm going to go in and show you how easy it is to create an autonomous database. You simply select that. It goes in my compartment. I can, of course, switch that. It gives a default display name, a database name. And here's your different versions: data warehouse, transaction processing, JSON database, and Apex. Now, Apex is a separate service unto itself. And if you don't need a whole database, you can actually subscribe to an Apex instance with a given amount, a certain amount of storage, and you can build applications without. But if you're going to use Autonomous Database, you're going to have Apex with the service in any case. Then there's shared infrastructure. We're going to use the shared infrastructure. We're going to start with one OCPU. You can, by default, it auto scales it up to 3 times the selected OCPUs. For what I'm going to be doing today, I just need a minimum version. Storage as well can auto scale, again, up to 3 times the basic storage, which the basic storage is 1 terabyte. And then you just have the admin user ID and the password. And you can make it private or not. In some cases, our customers need private access instead of public. I've made mine public. And then you do need to select a licensing option and then a choice of database edition, the enterprise or standard edition. And that's about it. That's all that's needed. And it only takes maybe 2 minutes to create the database. It's creating a pluggable database. And if you went into the VM version, DBCS, it takes more like about an hour and a half. It's got to deploy the entire database stack. So this is much, much quicker. So let's go into the data warehouse that I've created myself. I'm just going to point out a few things here. First of all, you'll see that I've got an Apex instance associated with it. I've got automated backups. That just happens by default. I have not implemented DataGuard, but it'd be as simple as just clicking enable, and it would ask you what region you want to deploy it to. Super simple. You can do it when you create the database or later enable it after it's been created. It's encrypted by default, as are all the Oracle databases in the cloud. You can see your scaling selections here. Mine scaled by CPU, but not by storage. And so, yeah, pretty simple. Let's go into the more actions. You can, of course, stop, restart, restore. You can very simply create a clone of the database. You can actually create a clone of a backup of a database now as well. Change the network access, set the password if you forget that. You can put it on a schedule, and I did this recently for my demo instances because I knew I wasn't going to be using them later in the evening or on weekends, and so I have a schedule that just automatically starts and stops on a schedule. There's some other features here, renaming the database, etc., and if you want, you can terminate it. You've got a scaling choice here. There's a performance hub. It can show you the kind of workload that you've got on the database and let you monitor that through this graphical interface. I have not been working with this too much today, so you'll see that it hasn't been under a lot of load. Let's go back. And we'll go back in here. Then we've got the database connection. This is relevant because when you go into the database connection, you've got the connection string right here. You can actually copy that here. But a lot of times we work with the wallet, and you'll definitely be working with wallets. If you're going to be setting up the SQL Developer Java client, it needs a wallet. If you're going to be using Instant Client, it needs the wallet. Any other service outside the database itself is going to need the wallet, and I'll show you that wallet in a little bit. It contains a number of files. It contains the wallet itself, but it contains a SQLnet.aura, TNS names file, and a couple of other files as well. And we'll take a look at that when we go into the Java client. And then lastly, database actions. And this is actually where we're going to spend a little bit of time taking a look at some of the features of the autonomous database. We'll go into database actions and we'll start it up. It only takes a few seconds to bring up the console. And in here you see a lot of different ways to access the database, different features that you can employ. This has been growing. When it first came out, Autonomous Database 3 or 4 years ago, we really didn't have that many choices here. We had SQL Modeler, not too many other options. So, and I'm not going to cover all of these. I'm going to cover a few things that we typically run into as a developer. But the ones I'm going to cover is SQL, the SQL interface here. It's like almost the equivalent of SQL Developer on your Java client. It hasn't got as many features and functions, but it is a nice web interface, so you don't actually need to install anything. I'm gonna touch on the machine learning. We'll go into that as well. We will not be going to Apex, but there's an Apex access to the Apex console here, access to DBMS scheduler. We're going to go into data load. I'm going to cover that. I'm going to go into data transforms. That's relatively new, and it's really quite a rich feature set in terms of being able to ingest data from Oracle and non-Oracle data sources. It's giving you a lot of the features and functions you have in Oracle Data Integrator in a very simple graphical web UI. And then one of the last things we'll do in here is go into data pump, show you how to import data so we don't have to run the command line. We will be running the command line later to do the exports. Today, this is a relatively new, fairly new feature, quite new. It only supports today import. I'm sure shortly it'll be supporting export as well. But when we do the exports, we'll be using the command line or DBMS data pump package to do that. So let's go into the SQL workshop, and you'll find it's pretty simple to use. I'm defaulting as I'm in as the admin user. There's permissions that each user requires in order to get into the console here, into the web UI. So you can control access to this. I'm going to switch to my demo schema, which has got most of my data. You'll see you've got a whole bunch of tables here, a bunch of tables to look at. If I wanted to look at, say, customers, I just drag it on here, and you got some choices here: insert, delete, update. I just want to look at the data. So let's just take a look at the data here, and then I'll just execute this. It's just kind of built out the select statement for me. And you can see you've got some options here: opening script files, saving, running scripts, etc. I won't be going again. This is just meant to be a high-level sort of introduction. And there's also a consumer group. You can change it by default. The database, the autonomous database, comes with 3 levels, 3 resource levels: low, medium, and high. Low for low memory, but high concurrency; high for high memory, low concurrency. The transaction processing version, this is data warehouse. The transaction processing version actually has a 4th. It's used for TP, transaction, high numbers of users, very high numbers of users, optimized for that. So here it is here. You've got a quick, simple UI. In order to look at data, I can execute any SQL I want in here, or PL SQL. I just write the code as you would in SQL Developer, or open a file as you would in SQL Developer, and just execute it here. And you can download this if you want to export the data back out. You can do that as well as CSV, JSON, XML text, etc. So yeah, super way of avoiding the clients, which is kind of the trend, of course, is to get away from stuff on your desktop. Again, me as kind of a long time developer, I still do stuff on my desktop. I would expect over the next few years, very few years, we're going to end up doing just about everything on the web, in the cloud, without actually doing development work on our desktop. So that's the SQL. Let me go back. And we'll go into machine learning. And again, this is really going to be very high level, but I thought it was important enough that we should come in and take a look at we're going to use the attrition user. With the attrition user, I've done some development work on building prediction models with that user. So I've got a couple of models to show you. Again, this is really high level. We've got projects. Projects are in workspaces, and workspaces have notebooks, very similar to data science. This is Zeppelin. It's an open source notebook technology. We use Zeppelin. And in data science, we use Jupyter. But anyway, let's take a look at some of the features here. We've got notebooks. And so notebooks have the ability to open up a notebook, start writing code. You can write SQL, PL/SQL, or Python. All of that works just fine. Let's open up and take a look at this one here I've been working on. And, strictly speaking, we do use this to build prediction models, but the reality is you can execute any SQL you want in here. So you could actually use it for other things besides building a prediction model. And so it supports, like I said, Markdown, which is %MD. I put an image here. You'll see that you've got the code there. You don't have to see the code. A workbook or notebook is comprised of paragraphs, and the paragraphs contain Markdown or SQL or PL/SQL or Python. And let's take a look at that. And some notes. It's very nice if you want to annotate your code and text. So it coexists the documentation for your scripting together with the code and script itself, whereas previously these would all be in separate. The documents would be one place, the scripting code would be another. And so here's where I've actually started playing with doing a side-by-side comparison of Python, which I've got here. And there's the Python with the equivalent SQL here. So we can list the data here using a Python command, or we can list it using SQL. Now, again, I'm not going to go into all the different things that you can do, but you can see there's visualizations here, charts. We've got PL/SQL here, charting, different charts, and different visualizations. Again, we have a separate presentation on this, and we have graphing, analysis of the effectiveness of the models, lots of code, and then looking at the results, looking at the effectiveness of the model. That's just giving you a brief introduction to that. If you are unfamiliar with the Oracle machine learning on the database platform, there is a great set of templates. So if we go into the examples here, I use this all the time, and there's 60 or 70, at least the last time I looked, 60 or 70 different sample notebooks in here that allow you to open them up and take a look at the code. And quite honestly, and for many problems, you can just read the code. It's all annotated and explained. You can look at the code and make sense of it, and then adapt it for your own model building exercise. So there's a bunch of these for Python and lots and lots of them. That's OML for PY, and then a bunch of them for R. Actually, the R one's in here. I forgot about that. And then there's the ones for SQL, OML for R, OML for Python, OML for SQL. So it looks to me like they've added many, many more since the last time I was in here. So this is a great trove of sample material that'll get you kickstarted on machine learning. So we're going to go back. We're going to go back to the database actions, and let's take a look at the next thing I wanted to cover, which is the data loading. And so I've been able to play with this a little. And, if you've been around Oracle for a while, you'll probably be able to come up with a good half dozen ways to load data into your database. Some of them are really fast. Some of them are really slow. I did a test very recently in the console here, and I hadn't played with it before, and I was pretty impressed. I had a 50 megabyte file, and it went up in about 1.8 minutes. And loading the same file in SQL Developer Client takes about 45 to 50 minutes. It loads about 1,000 records every minute or two. This one is vastly faster. And so you can literally just say data load. I want to load a local file. It just reads the file header. I select the file. And if I say, oh, I want to look at, let's go into documents, go into customer names, open, very, very simple graphical UI. There's the table name, and then I can just hit start. I mean, it can't be much easier than that. And so super, super easy. There's a few other things in here, but after you do the load, you can take a look at the load job. So let's go back into data load, and let's take a look at data load jobs. Data load jobs, I've done a load here already. You can see there, credit scoring, 100K load job. And this one took just less than 2 minutes. If you've got the jobs, you can go back and look at them, inspect the view, the details, take a look at what it did. There's a lineage, a nifty lineage here, the CSV to the file itself, log details, 100,000 rows, told you when it was, etc. So yeah, very simple, very easy. Doesn't get much easier than this. I think the only other way you get directly load into the Oracle database with this fast would be to upload to object storage and do a data load off that. And I'll show you actually how to create an external table and how you can replicate data, query data in a CSV file in object storage and create a copy of that table directly in the database. But it's fast as well. But a lot of the kind of methods that I've used with client tools in the past is pretty painful, painfully slow. So this is a really nice, simple alternative. So let's go back. And the last thing I want to cover in the last couple of things I want to cover is the data transforms. This is another pretty new feature. I'm pretty excited about it because I am kind of a data integration specialist in addition to database and analytics. And so we use Oracle Data Integrator, the legacy tool, over many years. It's pretty complicated, extremely capable and mature product. It can do just about anything, but it does take some investment of time. And so it's nice to get something that's super easy, and yet you can do more than just load the data, right? Sometimes you want to do some transformations. Now, so for the data transforms, it does take a couple of minutes to come up. Okay, so that took about 3 minutes, so not too bad. And so when you come into data transforms, the first thing you're going to need to do is create a connection, right? You're going to load data from somewhere and you're going to load it to somewhere. And we need connections for that. So if we go into connections here, you'll see I've got 2 connections right now. I wanted to do some testing against EBS. I had eBusiness Suite. I wanted to copy a big GL balances table, 8.2 million rows. And I thought, okay, I'm going to check that out. And so I defined a source here. If I go in here, you can edit the choice. Let's take a look at that. It's just a JDBC system password there, very conventional. But if we look at create connections here, you'll notice that out of databases, we've got large number of Oracle and non-Oracle databases, the Oracle ones being the conventional Oracle database, MySQL and MySQL HeatWave, but also object storage. You can create a connection to object storage, read and write to object storage. There's all these others here. Then there's application interfaces. And so if you want to go against Fusion, there's Fusion, Fusion ERP, Fusion Service, PeopleSoft, these other ones, BI Cloud Connector, right? If you're in Fusion, you'll be wanting to use that, NetSuite, etc. And then you've got services, Golden Gate, and data transforms. So it's pretty complete, pretty comprehensive, supported set of endpoints, connections. So that's nice. Then I've got this one here, which is my target. I'm going to load from here to here. I'm actually not going to actually do that job and run that job. I'll show you the jobs afterwards. But once you've created a connection, you're going to have entities, and the entities are the tables that you're going to pull back out of that connection. And your choice. I wanted to pull all the GL balances table names, the ones with the GL balances name like that. Of course, you can wildcard that. You can pull back all of the metadata for EBS, but that's thousands and thousands of tables, so be careful there. But anyway, your data entities are really your tables. And then when we finish that, we go into a project and we create a project. And a project has data flows. And there's the data flow here. And the data flow is really like your ETL. You're going to select your items. You're going to have a source. You're going to have a target. And actually, my database is on the other end. There's probably not running. So in any case, I'm not going to be going into this in a lot of detail, but you get the ideas that you drag your data entities on here for GL balances, for example, and then you're going to create a target table, and you may need to join it with other tables. You want to add expressions or aggregates, sorts, splits, subquery filters, all of these things. That's all typical stuff that you do with transform and load tool, and that's all free as part of the autonomous database. Any data that you need to be pulling from any other source in or out of Oracle, files, object storage, anything, you can really do that through the data transforms, and you can schedule it, of course, schedule it to run. Yeah, so we won't wait for this to come up. It's going to be dependent on my source databases, some of which I don't think the EBS is running. So we'll go back out of here, and then just the jobs themselves. I'd run and loaded the GL balances job, and not today. That was all time. So let's go back and look at some of those. GL balances load. I did another import as well, and it gives you some information about that. It's got the detailed steps here, the duration of each of those steps. It orchestrates all this for you. You don't really need to do any of that. So it's pretty slick. And let's take another look at this one. It's a little bit different. So that's just a very brief introduction to data transforms. Check it out if you've got access to an autonomous database and you want to try loading some data and doing some ETL with it. This would be the tool to use that for. So let me go back out here, and I'm going to switch over and put my legacy developer hat on, and I'll show you what it looks like in an autonomous database through the original client tool, which you'll be familiar with if you're somebody like me who's been around the Oracle database for some number of years. This is still supported. It's still available. How is it any different? All of these connections here are all autonomous database connections. What does the connection look like? I go into properties here, and you'll notice it's the same thing. It's Oracle database type is Oracle, username, password. The connection type is what's different here. You probably used basic, or you might have used custom JDBC, but you've got a cloud wallet, and all you do is upload the cloud wallet. You just select it on your desktop. You download it. Remember, I told you you'll be needing that wallet. Well, I'm outside the database now. I need the wallet. It actually is a zip file. It's got a bunch of files inside that wallet. And I selected the connection high. And that's as simple as it is. You just hit test, and it connects to the database, confirms. And we'll be going back in here later with some of the other stuff that I want to run with the DBMS data pump package. So I do want to show you the file. So if we go down here, and I'm going to go to my desktop, I'm going to go to wallets. I do have a wallet. And let's have a look and see what's in there. There's the cwallet.sso. There are some services, and I can't quite remember which ones. I think one of the integration tools, when it was prompting for the wallet, it actually meant this file, not the whole zip file. It might have been OAC, but just be aware, in most cases, you just supply the zip file and it extracts it automatically for you. Technically speaking, this is the wallet there, but there is also, of course, the SQLnet.aura and the TNSnames.aura. The connect string that I showed you on the console, it'll be in here, high, medium, low. Nice to be able to get it from the console directly, but if you wanted to use it, like, for example, Instant Client or previously with ORDS, I configured TNS names, although you can optionally directly enter the connection string in the SQL connection login process itself. But the TNS names is available right here. I have not really used these other files here, the trust store. I'm sure if you got into more advanced security, you'll probably be diving into some of these other files or needing them. So there it is there. That's just the wall. That's the SQLnet.aura. So yeah, so that's kind of all I really wanted to say. The actual, let me go back into here. Once you're in here, it's really the same. Like all the skills that you've used over years and years, you just run the same old SQL. You shouldn't really need to create indexes on the data warehousing side. I think that's now permitted, but things like partitioning as well. But there's a lot of auto tuning in ADB that's done automatically for you. The data stored for ADB anyway is stored in compressed columnar formats, so it's optimized for big queries for you. But really, kind of your development work is it's very much the same. This is, at the end of the day, a 19C database, and that's all you really need to know. So yeah. So now I'm going to move on to the DBMS cloud package. I use it almost every day. Very common. It gives me a lot of feature and functions. The first thing you do, though, that you'll probably need for almost everything is a credential. What is a credential? Well, when you access services outside the database, you need authentication, and you don't want to have your user ID and password in code. And so you create a credential once with it, and then you can reference that credential afterwards. So if I copy the code for that, I've already created a credential, but let's take a look at the code for that. This credential I'm using to log into not the remote database in this case. Actually, I use that for something else. But if I'm going to be logging and accessing object storage, files and object storage, I need my IDCS user ID and the password. I'm going to be also showing you the DBMS Cloud Repo package accessing Git user ID, Git content. Well, that's going to require a credential for my Git user ID and password. So I create a credential for that as well. And so, well, what credentials have I got? Let's have a look at that. Let's take a look at my credentials. And so I've got a Git credential. I call this token. Actually, I created this a long time ago. I've got too much demo material to change the name. It's not really a token, it's a credential. So it should, I think, more appropriately be called API cred. But in any case, it's the credential I created. This one I'm using to access services on in IDCS, like object storage or anything else that uses my IDCS cloud user ID. This is for Git repository. And let's see what kinds of things you can do with the DBMS cloud package. And for example, let me just list the files that are in object storage in my bucket. And here they are here. And there's lots and lots of them. It also includes the segments. So I did a big database export, and it pumped out 10 megabyte segments for a multi-gig file. And so it'll show you that as well. But so I even had, if you can access files in object storage, you can imagine that you can bury this in PL SQL packages. I did this for a large customer, built a PL SQL package that loaded data. And when people just dropped their files in object storage, it would rebuild the because the names could be different, it rebuilt the external table on the fly using a cursor, just pulling the names, rebuilt it, loaded it, dropped them. And so really you can do a lot of interesting things in PL SQL, accessing objects that are in your data Oracle directory, data pumpter, or your object storage, or even things like Amazon S3 storage as well. So let's show you what it looks like if we were going to access a data file and want to query it. So let's just create a very simple crime data, simple table, external table. So first things first, I'm going to drop it, and I've dropped it, and let's just recreate it. This is now reading from a file, a CSV file in object storage, treating it like it's a table. And so now right click, refresh. This is a sizable file, 150 megabytes, not huge, but not tiny either. And this is the data here. And this file has got about 700,000 rows in it and quite a few, several columns. And so, yeah, now you can do analytics on this. You can access this with Oracle Analytics Cloud. You can basically, it's to any other service, it's really just like an Oracle table. Of course, you cannot update it, but you can query it and join it with database data in database tables as well. I've run this against much bigger files, billions of rows, and it actually performs quite well. Obviously not as fast as if you load it into the database. It has no statistics that's recorded. The optimizer doesn't know how big it is. You can't create indexes on it, but it's an interesting way of accessing data that may not be in your database. You may even want to archive your data. It's a lower cost storage mechanism as well. So if you need to have low cost access to low cost storage, but you still need to run Oracle queries against it, this would be something you could take a look at using. Same as object storage now. We can access data in the data pump directory. We still use that. You're familiar with that. If you've been working with Oracle, you typically export data out to a Oracle directory, and then from there, you need to download it or do something with it. And so you can still do that right now. You can look at, even though it's a managed service, you can still update, you can still copy data into the directory and out of the directory. And you can also delete files in the directory, and we use the DBMS cloud package to do that. So we'll delete this chip4.dmp. So we'll do that. And once we've done that and we look at the directory again, we'll see that the file's gone. And so that's one way of being able to export directly to here and then move it to object storage or move it back again. The PL SQL package that we use to move data around is a put object or a get object. So this file here, I copied it. Actually, I did a put to object storage. And let's look at that file in object storage. And down here, you're going to see chipexport.dmp, and that's the file that I copied after I exported it out to the directory. I copied it here. When I want to import the job, I'm going to go into the console, and I think I forgot to show you that. Go into the Oracle database. I'm going to go to data pump here. I'm going to go import, and the bucket name, I've got to wait for it to refresh. I'm going to use share as my bucket. And I'm going to look at chip export. And next, import name is Webcast export, import. It's an import. Import type. Let's take table so we can be selective. Content, data, and DDL. Directory name now. So this is kind of important to know, is that if you're going to do an import from object storage, under the covers, it actually copies it to the directory. It copies it to the directory, the Oracle Data Pump directory here. And you don't sort of see that, but that's what's happening under the covers. And when you finish the data pump import, the file is left there. So if you don't want it to be there, if it's very large, you'll go back into DBMS Cloud and drop that file. So that's just something to be aware of, because you're thinking, well, look, I'm importing that from object storage. Why is it asking me for the directory name? Well, that's why it needs a directory in any case. And you'll see it in the code. I'll show you the code when this finishes. Of course, in impdp, the command line that you'll be familiar with, you can do the same sort of thing. But again, you'll need to have the commands at your fingertips. And this just means you can do all these things without actually having to remember all the commands. And so here are the files that are in here. So if I decide, oh, I want this table, I go next. I can do a remap here. So the source is demo in this case, and the target is demo, but you can do a remap of table spaces and schemas here. I'm going to leave it as is. And then you've got choices here, truncate, replace, none. I'm going to leave it right now because I'm not actually going to execute this, but I do want to show you what the code looks like when we get to the point where we're actually going to kick it off. And so here it is here. It tells you what your options were, but you can say show code. And this gives you an insight into exactly what's going on. And of course, you could copy this right up here and execute it in SQL+. And so you could, this is basically a code generator for you. And if you look through here, you'll see no reference at all to the object storage URL. And so when you execute this file ends up Oracle directory after it finishes and completes the import. So again, I'm not going to actually complete that. So I said that the console itself does not support exporting of data. So you'll have to do that in some other way. Of course, again, if you use the EXPDP, you would need to have the CLI installed, the command line interface installed, and or instant client installed. But you can also, of course, just execute it here through SQL. And so take a look at this. I will not execute this. It takes a while. And so this is the specification of the job. It's a DBMS data pump job. You add the file. There's the file name that's going into object storage. And then their directory is there. And then the schema name is demo right there. And then you can execute this. It kicks a job off. And so it says when you see the job successful, all it did is the success messages that it successfully submitted the job, not that the job itself was successful. So just be aware of that. And of course, there's you can look at the status of the job by issuing this command here. So if you kick off a long-standing job, you'll see this one's finished. It's not running, but those jobs will show as running. And then when they're completed, they'll fall off this. So I do want to touch on a couple of things. So when you do an export to object storage, let's take a look at see what that looks like. If I go into here, I go into there, I go into storage, object storage. And this kind of tripped me up a little bit. So I want to bring this to your attention. That's the export that happens. You have no control over the segment. The ADB export 4.dmp is 0 bytes. and it creates segments, and you can't control the size of these. I looked all through the documentation. You can imagine this is a 2.5 terabyte, 2.5 gigabyte, creates quite a few files. And I saw notices from people saying they had 80,000 of these segments if it's a massive export. But just so you know that this is what gets created. And then when you have these multi-part, multi-segment export to object storage, and you go into the console to do the import, it errors out, because when you pick this ADB export for 0 bytes, it says, look, there's nothing in there. And so you have a choice. Here's a couple of choices. You either export to, like this one, export to the data pump directory, and then use this code here to copy it. Let me show you that. So you export out to, and then you copy it. It's a put command, and you put it out to object storage. And then it'll be one big file. It'll be one big file. Or you do a get of that multi-part object, and it comes back into the data pump directory in one file. So the export, this put or get object statement will preserve the size of the file and not put it into different parts. And so, yeah, that's kind of, if we go back to object storage here, this one here, when I would put it back into the data pump directory, it was one file, and I could import it. When I exported the same file out to data pump directory, and I called it demo export in this case, it copied over to here in one big file. So it's kind of a two-step process. There's no, the way I can see it, there's no way of getting around that. I'll show you one more thing here before I leave DBMS data pump, and that is I can export, as I told you, I can export out to to a data pump directory. And that's what I did here. That's it here. It's export, it's a schema. I commented if you wanted just a table, you just change the job mode to table. Jobs, demo export. Just be aware that once you use that job name, it stays out there. You have to use a different name. So it'll, if I rerun this, it'll error out and say that job already exists. Even if it completes, it already exists. So you'll have to constantly rename the jobs, just FYI. And now I exported this out to data pump dir. It was demo export. Remember, you saw that 2.35 gigabyte file. It's this one. And again, if you want to filter by a particular table, there's the filter. I commented that out as well. But that's really how the data pump works, and the DBMS cloud works. You use those kind of all the time, especially the DBMS cloud one. I do want to show you, just touch on the documentation, which is really good. It gives you some insights into what you can do with data with the DBMS cloud package. And this is just the documentation, but I think it's useful because you'll see kind of the things you can do: bulk operations for files in the cloud, bulk copy, bulk move, bulk download, bulk upload, bulk delete, monitor, troubleshoot. So lots and lots of things you can do. These are really handy packages. And the other one I want to show you is this one. And this is richly functionally rich. Collections, copy data, create external table. We did that. Delete operations, delete files, delete objects, files in the directory, files in the object storage, right? Objects or object storage files are in the directory. Get, put, list files, list objects. I did a list objects. You saw that as well. Validate external tables. So there's tons of these things. You'll be using this a lot if you're in the cloud. So we're going to move now on to DBMS Cloud Repo. And let's take a look at the documentation briefly with that, and then we'll go into DBMS Cloud Repo. DBMS Cloud repo packages, it allows you to manage your files, your database files, scripts in a Git repository instead of, say, in a file system or somewhere else. Git's very popular. We use it in our team all the time. And so I thought we should cover that today. So let's take a look at some of the things you can do with the package. Now, remember that I've created a credential already, so don't forget, you'll need a credential for your Git repository. And once you have that, we can query and see the repositories. What are the repositories in my GitHub repository? What are the repositories that I own? We have tons and tons of them on our team. And so, yeah, you can list the repositories. And again, if you need to manipulate data, you can use PL SQL to do that. Now let's list the files in one of my repositories. And so I've got a couple ones here in this one ADB repo that I created. So I created that with PL SQL. I created a GitHub repository with PL SQL. And then I put the files in there, right? And you can create a repo. I'm just going to show you the code for that. I won't actually execute it. And there it is there, create repository. You can have the JSON inline or separate. You can put it in a separate variable, but I put it inline here. The provider and the owner, LDA. And again, I have my Git credential, so my user ID password's in there, and there's the description there. If I want to export the table, which is what I did, the create ticker.sql, that is in my GitHub repository. How did I do that? How did I export the DDL for that? It is this code right here. All you do is say export object. Now it's not the data, to be crystal clear here, it's the DDL, the definition of the table. Object type is table, object name is ticker. It's this, basically it's this ticker table down here. It's the DDL for that. And so what's probably a lot more interesting and powerful is exporting schema DDL, because that, as you can imagine, for a schema with hundreds or thousands of objects in it, if you were to do that manually, I just don't know how long that would take you. It'd be very painful. And so it then exports the schema out to the GitHub repository. Let's take a look at that. I'm going to go to my GitHub repository, Git DG Cameron, my repositories, my ADB repo. And here it is here. Let's take a look at ticker. There it is there, create table, blah, blah, blah. You can execute that. And by the way, I'm going to show you how to execute that code. Like, you can export it, but then you can bring it back. Let's go back here. This one is much, much larger. Every table, every view, every PL SQL, it just goes on and on and on. So that is a super useful command for backing up your DDL from your database schema. And what is the code to they call it install file. I find that a little bit odd choice of syntax. It's not installing, it's executing SQL code, whatever that SQL code is. And so there it is there. I just pass the name of the repo, credential, the name of the file, and that's how simple it is. I could then drop this table, execute this, and it would recreate it from the GitHub repository script. So that's all I have on the GitHub integration. Check it out. So let's move on to SQL command line, or they call it SQLCL. It's just a Java client download from Oracle. Very simple. You just download it and unzip it. I have put it into Home D Cameron application SQLCL. And so when you do that, you can change directories to the bin directory, and then you type, let's log in and do some stuff with SQLCL. Again, you could do this in a compute instance on the cloud as well, but I'm doing this actually locally. SQLCL is also part of the Cloud Shell, which I'll cover at the very end. So if I do paste, I'm going to connect to SQL. And I need to set the configuration of my wallet. Remember, sort of harping on this, if you're working with an autonomous database, you need the wallet. So I'm going to set my configuration here, and it points to my wallet path. And then I'm going to connect. I'm going to connect to my low service here. I'm going to connect, paste. And so I'm logging in, and I've got to submit my password. Let me enter that. And I'm connected. I'm connected into the demo schema on my autonomous database through SQLCL on my desktop. And then at this point, you can go DP help examples. So DP is short for data pump. So this is just another choice. Remember, I was doing everything in SQL, like in SQL Developer. I could do it in SQL Web. Well, but if you want to do these things outside the database, calling by connecting into the database without using a client like that, you can use the DP command. So DP help examples. And so you can see there, and you can actually do a data schema export. And I'll show you the command for that. I'll actually not do it. It takes a few minutes because we've got a fairly large schema here. I'll put the command in, and you'll see that. There it is there, export schema demo. The API token credential, that's the -C as a credential. The URL, there's the URL, and then it's just out to the webinar.dmp. If you wanted to output a table in CSV format, it's got some SQL Plus-like formatting options. So let's do that. Paste, set SQL format CSV. I'm going to spool the departments. I'm going to do that. Paste. I'm going to spool a file called departments. And I'm just going to say select star from departments. So this is kind of one way of downloading data, I suppose, but there's the 20, and then spool off, and then just exit, and then just ls, and then just do cat, and there it is there. And you could do exactly the same thing in the Cloud Shell. Let's just go back into the console here. And if I go into here, I can go, this is your cloud console. You're not in a database. You can be anywhere in the console here. You have access to some tooling right here, Cloud Shell code editor. And this spins up really a instance of the command line inside the cloud console. It defaults to your home directory, and you have 5 gigabytes of storage in your home directory, and it persists. It's like having a permanent image. So I've got some stuff I've been doing. There's the departments.csv. I did the same thing there. I've got my wallet up there because I'm using it all the time. I got some Python code, product catalog, some other things, but this is all my personal storage, and it's always available through the console. It's an alternative to using, say, your desktop or using, say, some compute image on the cloud. Now, you can use SQLCL on here. The instant client's in here. Liquibase is not. And so that's the last thing I'm going to show you is a pretty interesting feature called Liquibase. It's an open source solution for replicating DDL changes across databases. So let me show you that. I'm going to exit out of here. Let's just have a quick look at the documentation. Using Liquibase as an open source database independent library for tracking, managing, and applying database schema changes. For an understanding, see the major concepts documentation. So say you have, like I do, you have this demo schema, and you have a lot of content in the demo schema. Never mind that. And you have a second database. It could be the same database. It could be just a separate schema. And in this schema, you have nothing. You have nothing. So you want to replicate all of the objects. If we go expand the tables down here, you'll see there's nothing in demo 2. You'll see there's a lot of objects in demo. We are going to replicate demo to demo 2, and then moving forward, continue to keep those synchronized through the use of Liquibase installed in through the SQLCL. Let's go back to the command line here. SQL no log again. We're going to set our config, and we're going to connect to our source demo schema. I'm connected. LB generate schema. This is going to take a few minutes. I will pause the recording as it generates. So that took 2 or 3 minutes, completed successfully. The next thing, I'm going to connect to the target. I have to enter my password. I'm going to issue a LB update changelog controller file. It's a configuration file that tracks changes. And that will take a minute or 2. So it's finished, and we should have all the objects that were in demo replicated to demo 2. Let's just have a look at the files that were created. You'll notice here, we look at all these XML files. These were all generated in the directory where I logged in. All of these are generated, the XML files, in addition to the manifest file, the controller.xml file, and logging. All of this was generated. We should see that now in SQL Developer. Let's go over here. And now we're in demo 2. You see we've got nothing there. Right click, refresh. And there's all your objects replicated with 2 commands. One is the LB generate schema on the source. And the second was an LB update changelog controller on the target. And anytime you want to refresh these, is that if you go back on the source, you make an altered table change on the source up here, all you do is it would just recapture any changes moving forward. It doesn't do the whole schema. It actually tracks changes and deltas moving forward, and then applies those changes to the target side. So pretty useful. You could, of course, use this data pump without data, but I think the LB also tracks changes and deltas moving forward. So for teams working on migrating from dev to test to prod, this would be one way of doing that. It captures not just table changes, but views, indexes, etc., all the different objects. So I hope you found this presentation useful. I've tried to capture and encapsulate all the things that I ran into as a legacy database developer over many years, and all the things that I've learned in the last few years with the Oracle Cloud, and how things have changed, and actually how things are much easier. And there's a lot of new things that you can do much easier now in a cloud environment than you could working with an on-premise database, not to mention the fact that you now don't need to install and configure databases anymore. That used to be a big part of what I did. And so this is, I think, much more enjoyable as a developer, rather than having to deal with installation. Thank you.